So this should be EP star. So this should be here. E0 square e to the power 4 epsilon 0 square m square c to the power 4 r square. এখানে f star আর এখানে হচ্ছে ff star. So this should be ff star and আর আমি যখন এদের প্রোডাক্ট নেব, এদের প্রোডাক্ট একটা হচ্ছে with negative sign আর একটা part হচ্ছে with obviously the positive sign. So you are actually taking here the product of, যদি আমি এই দুটো ধরি e to the power minus twice pi l s minus s0 dot n1 a1 by e to the power minus twice s minus s0 a1 a1, এই দুটোর প্রোডাক্ট যদি আমরা ধরি e to the power twice pi l আমরা n1 a1 minus 1, তাহলে এটা হচ্ছে এই ফর্মে e to the power in minus 1 divided by e to the power ix minus 1. This multiplied by e to the power minus inx minus 1 e to the power minus ix minus 1. তাহলে এই দুটো প্রোডাক্ট e to the power inx minus 1 e to the power ix minus 1 e to the power minus inx minus 1 e to the power minus ix minus 1, এদের প্রোডাক্ট যদি নেই, this should be nothing but it should be equal to sine square nx divided by 2 divided by sine square x divided by sine square x divided by 2. So obviously প্রত্যেকটা ইন্ডিভিজুয়াল প্রোডাক্ট, one with negative sign, one with positive sign, এদের প্রত্যেকটা প্রোডাক্ট যদি নেই, because you have consider EP star, তাহলে এখান থেকে তোমার থাকবে sin square, তাহলে এখান থেকে তোমার থাকবে sin ff star, তার পরের টার্মটা আসবে sin square pi by lambda s minus s0 dot n1 a1 divided by sin square pi by lambda s minus s0 dot a1, এটা একটা টার্ম। নেক্সট টার্ম থাকবে sin square pi by lambda s minus s0 dot n2 a2 divided by sin square pi by lambda s minus s0 dot a2, আর একটা থাকবে হচ্ছে sin square pi by lambda s minus s0 dot n3 a3 divided by sin square pi by lambda s minus s0 dot a3. So you get e0 square e to the power 4 divided by ip scattered into the ep star e0 square e to the power 4 epsilon 0 square m square c to the power 4 r square ff star, সেটাকে আমরা লিখতে পারি এইভাবে। আমরা যদি এটাকে আবার লিখি আরেকটু মডিফাই করে, sin square, এইখানে তিনটে টার্ম থাকবে sin square pi by lambda, একটা involving n1 and involving n2 and involving n3. So you get from this ultimately, this is your IP, this is equal to I0. এখানে এই E0 square এর বদলে আমরা লিখতে পারি this is the incident intensity I0 e to the power 4 divided by epsilon 0 m square c to the power 4 r square. This is f square mod f square, then sin square pi by lambda s minus s0 dot n1 a1 divided by sin square pi by lambda s minus s0 dot a1 তাহলে এরকম আরো দুটো টার্ম থাকছে, সাইন স্কোয়ার পাই বাই ল্যামডা s minus s0 dot n2a2 divided by sin square pi by lambda s minus s0 dot a2, আর ফাইনালি আমরা পাবো sin square pi by lambda s minus s0 dot n3a3 divided by sin square pi by lambda s minus s0 dot a3. So this is the scattered intensity at the point P. Now, again, from here we can derive the three-law equation. Now, the three-law equation we can derive the value of the intensity. This value of the intensity at the point of intensity at the point of observation depends. The value of the intensity, the value of the intensity at the point of observation depends on the three cosines of the equation, depends on the three cosines, depends on the three cosines of the equation. And these are of the form, এইখানে যে কোনো একটা ফর্ম যদি আমরা ধরি, these are of the form y equal to sin square nxi divided by sin square xi, where xi equal to pi by lambda s minus s0 dot ai. Now, this function becomes maximum only at xi equal to pi by lambda s minus s0 dot ai. This is equal to n pi. কারণ এটাকে যদি আমরা প্লট করি, this is, you will find that is sin square nx divided by sin square x versus x. So here the function rise to maximum, the function rise to maximum, the function rise to maximum at the position, the function rise to maximum at the position x equal to n pi, where n is an integer including 0, where n is an integer, where n is an integer including 0. The function is maximum, rise to maximum at the position x equal to n pi, that আমরা দেখেছি, where n is an integer including 0. Therefore this function y equal to sin square nxi divided by sin square xi is essentially 0 everywhere, except in the immediate neighborhood of x equal to n pi. That's the function. কারণ এই ফাংশনটা দেখা যাচ্ছে শুধু 0, pi, 2 pi এই জায়গাগুলোতেই হবে ম্যাক্সিমাম, আদারওয়াইজ ইট শুড বি 0. সেটাই বলছি, this function thus the function y equal to sin square nxi divided by sin square xi, which is actually coming out from this factors. These are the factors, these are the form. So this function y equal to sin square nxi divided by sin square xi is essentially 0 everywhere except in the immediate neighborhood of x equal to n pi. So it is 0 everywhere except in the immediate neighborhood of x equal to n pi. So hence the intensity will be 0. Hence the intensity in the scattered intensity will be 0. unless the three quotients are maximum. Hence the scattered intensity at the point will be 0 unless the three quotients are maximum. তাহলে একটা maximum আরেকটা 0 হলে this should be totally 0. So hence the intensity will be 0 everywhere unless the intensity will be 0 everywhere unless the three quotients unless the three quotients are simultaneously close to the maximum value, are simultaneously close to their maximum value. তার মানে we can say that pi by lambda s minus s0 dot a1. So this is your xi, this is your so here we have called that is your this is the function that is your pi by lambda s minus s0 dot a1. So this should be equal to n pi. তাহলে আমরা বলতে পারি for the three directions pi by lambda s minus s0 dot a1, this should be equal to h pi by lambda s minus s0 dot a2, this should be equal to k pi. So and pi by lambda s minus s0 dot a3, this should be equal to l pi. এখন এখান থেকে পাই যদি আমরা করি, so you would be getting this is a1 dot s minus s0, this should be equal to h lambda. This should be second equation থেকে আমরা পাবো a2 dot s minus s0 equal to k lambda, আর এখান থেকে a3 dot s minus s0 equal to l lambda. So you got three Lau equations. These are the three Lau equations, and it actually gives you the condition. It gives you the condition at which the three Lau equations, which gives you the condition at which the scattered intensity at the point P is going to be maximum. Now, after getting the Lau equation, we can now introduce the reciprocal lattice vector here. Now, we define a vector. G equal to twice pi by lambda s minus s0. So 2 pi by lambda s, this means your scattered direction, and 2 pi by lambda s0 মানে হচ্ছে incident direction. So এটা হচ্ছে this is your scattered wave vector minus your incident wave vector, that is your delta k. So if you call this is your k minus k0, that is zero. So obviously the Lau equation, in the Lau equation you can if you try to introduce the reciprocal lattice vector into the Lau equation, তাহলে আমরা বলতে পারি a1 dot g, this should be equal to a1 dot 2 pi by lambda s minus s0. This is 2 pi by lambda. This is 2 pi by lambda a1 dot s minus s0, that is 2 pi by lambda a1 dot s minus s0 আমরা পেয়েছি, this is h lambda, this is h lambda, so you get 2 pi h. তেমনি আমরা পাবো a2 dot g equal to 2 pi k, and A3 dot G, this should be equal to 2 pi L. So you get, after introducing the reciprocal lattice vector, the Lau equations becomes A1 dot G, this should be equal to twice pi H, A2 dot G, this should be twice pi K, and A3 dot G, this should be equal to twice pi L. So these are the three Lau equation after introducing G, that is the reciprocal lattice vector. Now, for orthogonal axis system, the equation 3 are satisfied. For orthogonal axis system, the equation 3 are satisfied if we take G of the form, if we take G of the form, for orthogonal axis system, the equation 3 if you call, এবং এটাকে যদি আমরা বলি, এই যেটা আমরা বলেছিলাম g equal to, যখন আমরা এক্সপ্রেস করেছিলাম, এটা হচ্ছে 2k, so this you expressed as your equation 2, আর এটাকে আমি এক্সপ্রেস করলাম a1 dot g equal to twice pi h, a2 dot g twice pi k, a3 dot g 2 pi l, এটাকে আমরা ইউজ করলাম equation 3. So this is obviously this is the equation 3, and obviously for orthogonal axis system, this should be satisfied provided G is of the form. If we take G equal to twice pi HB1 plus KB2 plus LB3. So this is for orthogonal axis system, the equation 3 are satisfied if we take G equal to twice pi HB1 plus KB2 plus LB3, where B1, B2, B3 are the basis vectors, which satisfy these conditions. তাহলেই তুমি যদি জি এর আমি এই ফর্মটা ধরি, then it would come to the relation, that is your equation 3, provided a1 dot b1, this should be equal to 1, a1 dot b2, this should be equal to 0, a1 dot b3, this should be equal to 0, a2 dot b1, this should be equal to 0, a2 dot b2, this should be equal to 1, and a2 dot b3, this should be equal to 0, a3 dot b1, this should be equal to 0, a3 dot b2, this should be equal to 0, a3 dot b3, this should be equal to 1. So তাহলে এইখান থেকে আমরা বলতে পারি this lattice constructed with basis vectors, the lattice constructed with the basis vectors, the lattice constructed with the basis vectors, with the basis vectors b1, b2, b3, the lattice constructed with the basis vectors b1, b2, b3 are called the reciprocal lattice, corresponding to the direct lattice. So lattice constructed with the basis vectors, b1, b2, b3, b1, b2, b3 are called the reciprocal lattice corresponding to the direct lattice. So এখানে যদি তুমি a1 dot g করো, so you will be arrive this a1 dot g equal to 2 pi h, a2 dot g should be 2 pi k, and a3 dot g should be equal to
2 pi L. So these equations are satisfied provided for orthogonal axis system. If you take G equal to twice by HB1 plus KB2 plus LB3, where B1, B2, B3 are the basis vectors which satisfy A1 dot B1 equal to 1, A2 dot B2 equal to 0, A1 dot B3 equal to 0, A2 dot B1 equal to 0, A2 dot B2 equal to 1, A2 dot B3 equal to 0, A3 dot B1 equal to 0, A3 dot B2 equal to 0, and A3 dot B3 equal to 1. So this is the relation for the orthogonal axis system, how a basis vectors of direct lattice and the basis vectors of the reciprocal lattice are related. And from this we will take the different properties of the reciprocal lattice vector. Now the main important thing here, that is the যেটা আমরা বলি, that is your reciprocal lattice vector. যখন আমরা for non orthogonal axis সিস্টেমের দিকে যাই, the reciprocal lattice vector G has the following properties. The reciprocal lattice vector G, এই প্রপার্টিসটা আমরা যেটা দেখলাম, this is for orthogonal axis system. এবারে অন্যান্য সিস্টেমের ক্ষেত্রে আমরা যদি যাই, the reciprocal lattice vector G has the following properties. One is the basis vectors of reciprocal lattice are related to the basis vectors of direct lattice. The basis vectors of reciprocal lattice are related to the basis vectors of direct lattice defined by B1 should be equal to A2 cross A3 divided by A1 dot A2 cross A3. So this is one. Then B2 equal to A3 cross A1 divided by A1 dot A2 cross A3, and V3 should be equal to A1 cross A2 divided by A1 dot A2 cross A3. So this denominator, the denominator প্রত্যেকটা ক্ষেত্রে যদি আমরা denominatorটা দেখি, the denominator is the volume of the unit shell of the direct lattice. The denominator is the volume of the unit shell of the direct lattice. So this is for non-orthogonal axis system. If you take how the reciprocal lattice, how the basis vectors of the reciprocal lattice are related to the direct lattice basis vectors. So B1, B2, B3 are the basis vectors in the reciprocal lattice, where A1, A2, A3 are the basis vectors in the direct lattice. And second characteristics the volume of unit cell in direct lattice. The volume of unit cell in direct lattice is reciprocal to the volume in reciprocal lattice. The volume of unit cell in direct lattice is reciprocal to the volume in reciprocal to the volume in reciprocal lattice. The volume of the unit cell in direct lattice is reciprocal to the volume in direct lattice. So this is the you can call the second property. Third property is the problem, that is you take the reciprocal lattice vector G equal to twice pi HB1 plus KB2 plus LB3 characterized by integers HKL is normal to the reciprocal lattice vector G equal to twice pi HB1 plus KB2 plus LB3 characterized by integers HKL. In the HKL is normal to the set of planes, defined by HKL in the direct lattice. The reciprocal lattice vector G equal to twice pi HB1 plus KB2 plus LB3 characterized by integers HKL is characterized by integers HKL is normal to the set of planes defined by HKL in the direct lattice. So this is the properties as well as we take it as a problem. And the another problem which is also a property of this, and এটা আরেকবার বলে দিই, the reciprocal lattice vector G equal to twice pi HB1 plus KB2 plus LB3 characterized by integers HKL is normal to the set of plane defined by HKL in the direct lattice. The fourth one is the fourth one. This is your the interplanar spacing. The interplanar spacing DHKL between successive planes of Miller indices HKL in the direct lattice HKL, the interplanar spacing DHKL between successive planes of Miller indices HKL in the direct lattice is equal to 2 pi by GHKL, where is equal to the interplanar spacing DHKL between successive planes of Miller indices HKL in the direct lattice is equal to 2 pi by magnitude of reciprocal lattice vector GHKL, where GHKL is the magnitude of reciprocal lattice vector lattice vector GHKL defined by integer, where magnitude of GHKL, where GHKL is the magnitude of reciprocal lattice vector GHKL defined by integer HKL. So the interplanar spacing DHKL between successive planes of Miller indices HKL in the direct lattice is equal to 2 pi by magnitude of GHKL. So সেটাই আমরা elaborate করেছি what is actually meaning of this, that is where GHKL this denote the magnitude of the reciprocal lattice vector GHKL defined by integer HKL. So you take it as a problem and you try to show this also become the property. So other properties are also there. So we'll try to go through in the next class. So next class is সেটা আমরা বলার চেষ্টা করব, that is this part, that is your remaining part of the properties of the reciprocal lattice. তাহলে আমি এখন চারটে properties reciprocal lattice বললাম. We have derived the Lau equation. Lau equation এর পরে আমরা reciprocal lattice introduce করলাম. তো প্রথম আমরা করেছিলাম কি না, scattered intensity এটা বার করলাম at any point P by considering the scattering of X-ray by all atoms in the crystal, and we have found out this expression. এবং এখানে আমরা দেখেছিলাম the science factor এগুলো যদি আমরা প্লট করি sin square nx divided by sin square x plus x এই ফর্মেই আছে এটা, এই ইকুয়েশনস গুলো। তো এইটাকে যদি আমরা প্লট করি তাহলে দেখা যাবে ইউ গেটিং ম্যাক্সিমাম অনলি অ্যাট এক্স ইকুয়াল টু এন পাই, যেখানে 0, পাই, 2 পাই এগুলোতে পাবে, আদারওয়াইজ ইট শুড বি 0, কারণ এখানে দেখা যাচ্ছে আদার পয়েন্টস ইট ইজ অলমোস্ট ভ্যানিসেস। সুতরাং এইখানে যদি স্ক্যাটার্ড ইন্টেন্সিটিটা ম্যাক্সিমাম হতে হয় তাহলে এদের তিনটেকেই সাইমালটেনিয়াসলি ম্যাক্সিমাম হতে হবে। এই সেকেন্ড থেকে ইউ গট দা that is that conditions requires that a1 dot s minus s0 equal to h lambda, a2 dot s minus s0 equal to k lambda, a3 dot s minus s0. So you get the three Law equation, এবং সেই Law equation যখন আমরা reciprocal ল্যাটিসটাকে ইন্ট্রোডিউস করলাম, you got the Law equation in terms of reciprocal lattice a1 dot g equal to 2 pi h, a2 dot g equal to 2 pi k, a3 dot g equal to 2 pi l. And then you got the কিভাবে রেসিপ্রোকাল ল্যাটিস ভেক্টর তোমার যেটা কিভাবে রেসিপ্রোকাল ল্যাটিস ভেক্টর কনস্ট্রাক্টেড হয় সেটা আমি বললাম একটু। that is the lattice constructed with basis vectors b1 b2 b3 are called the reciprocal lattice corresponding to the direct lattice। তখন আমরা ডিফাইন করলাম সেইভাবে, যেখানে জি কে আমরা ধরলাম জি ইকুয়াল টু টুয়াইস পাই এইচ বি ওয়ান প্লাস কে বি টু প্লাস এল বি থ্রি। অর্থোগোনাল অ্যাক্সিস সিস্টেমের ক্ষেত্রে you take this is your reciprocal lattice vector, এবং এই ক্ষেত্রে b1 b2 b3 আর the basis vector। সুতরাং এইটা দিয়ে যদি আমরা একটা ল্যাটিস কনস্ট্রাক্ট করি তাহলে that will corresponds to the reciprocal lattice to the direct। এবং সেই কারণে তার প্রপার্টিজ গুলো আমরা দেখছিলাম। রেসিপ্রোকাল ল্যাটিসের চারটি প্রপার্টিজ আমরা বললাম, তার মধ্যে দুটো to take it as a problem, so we'll discuss it in the so so obviously এই করে আমি এখন শেষ করছি ক্লাসটা। আমি আবার tomorrow morning যদি সম্ভব হয় I'll also again join around 8:30, okay? আমি আজকে ক্লাস এখনই শেষ করলাম, তোমরা যেরকম ওই এটা নাও অ্যাটেন্ডেন্সটা। ঠিক আছে, আমি বেরিয়ে যাচ্ছি, ওকে?